Okay, so hi. Now let us, test, do the hypothesis testing for a single mean. Test for a single mean. This is my topic. Test for single mean. Okay. So the question is given over here. A random sample of 100 recorded deaths in the United States during the past year showed an average lifespan of 71.8 years. Assuming a population standard deviation of 8.9 years, does this seem to indicate that the mean lifespan today is greater than 70 years, right? So, over here, they are asking to check whether the mean lifespan today is greater than 70 years. So, H naught will be what? H naught will be mu, okay, mean less than 70, okay, this is equal to 70, and H1 is going to be mu greater than 70, all right? So, this is my hypothesis. So the first step is to form hypothesis. All right. Now, okay. Now the next step is to check your alpha. Alpha is given us what? LOS, nothing but 0.05. So over here, right? Let me show you. So basically, this follows a normal distribution. We know normal curve is what? The normal curve is like this, right? This is your mean, so and so. So when you give you alpha 0.05, there's something called as Z alpha. Z alpha is equal to, it is nothing but 1.645. Okay, this will be given to you in the test itself. You don't have to know this thing. Okay, this will be given to you in a test. So Z alpha is nothing but 1.645. That means what? Over here, this is 1.645. Okay, so it means that this is the critical region. Okay, and this is the acceptance region. Okay, region. This is critical region. This is the acceptance region. This is the critical region. This is acceptance region. Okay. So next step over here is to find the test statistic. Okay, is given by z is equal to x bar minus mu by sigma by root n. Okay, when x bar is the sample mean, it is given as what? It's given as 71.8. Mu is equal to 70, right? It's given no testing mu is 70 or not. No, that is mu is 70. Then we have sigma is equal to 8.9. Right? Sigma is nothing but standard deviation. It's given here as 8.9 years. All right. So I will calculate this value. So z and n is equal to the sample size. It's given as 100. So z is equal to x bar 71.68 minus 70 by 89 by root 100. Okay, must find this. And his answer is coming as 2.02. Now this 2.02, okay, is beyond this thing. Right? This 2.02 is greater than this so and so. Is greater than 1.645. If you can see over here, 2.02 is greater than 1.645. So it lies in this region. It lies in this region. So this the lies in critical region. Hence 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 we reject H naught and accept H1 and Hence, you can claim that this one. Hence, you can claim that we can claim that the mean age is greater than 70 years. Alright, because why? First of all, what did I do? First, I checked. First of all, I set up the hypothesis. We learned how to do it in previous videos. We checked the alpha, okay, 0.05. This value will be given to you. Don't need to worry about it. This will be given to you in the test exam. So I'm just plotting it over here. So over here, it is a less than equal to sign, right? This is the 1.645 over here. So beyond this is the critical region. All right. This is a left tail test, right? So right tail test because of this greater than. So this is a right tail test. Hence, this is greater than over here. This greater than comes here. So what is beyond this is critical region. Okay. Hence, you find test statistic is given by x bar, the sample mean minus mu, the population mean, by sigma given to you by root n. You get 2.02. This 2.02 is greater than 1.645. Hence, it falls in critical region. Hence, you reject H0 and accept H1. So, this is how you will test the hypothesis. Alright. Let us do another question. Over here, is given that a manufacturing sports company has developed a new synthetic fishing line that a company claims as a mean strength of 8 kilograms with a sand deviation of 0.5 kilograms. Is not equal. Okay. There's the hypothesis that mu equal to 8 kilometer against the hypothesis that mu not equal to 8 kilograms. If a random sample of 50 lines is chosen, tested and found a mean of breaking strength of 7.8 kg. So how do we do this? First of all, for my hypothesis, H naught mu is equal to 8 kilograms. Okay, H1 mu not equal to 8 kilograms. All right, alpha equal to 0.01. Okay, now this is a two-tailed test, right? This is a two-tailed test. So you draw your graphs here. Okay, so where this because not equal to sign and this. So whatever falls here, if your test statistic falls over here, means you reject H naught. Got it? So it's given alpha equals 0.01. Alright. So over here, my Z alpha is nothing but 2.575. That means what? This is going to be minus 2.575. This will be 2.575. So if a test statistic lies between this and this, I accept H naught. If it lies beyond this number or beyond this number, that means I will accept H1. All right. So let me do the calculation now. So I have Z is equal to x bar minus mu by sigma by root n. Okay. So x bar is given as sample size. Sample mean is given by what? 7.8, right? 7.8. 7.8 minus 8 by sigma is given as 0.5. 0.5 by root n, which is root of 50. Okay, is equal to 0.2 by 0.5 by root 50, which is equal to minus 2.83. Okay, so this minus 2.83 is beyond this side, is beyond this 2.7575 minus 2.575, lies here somewhere. So hence we hence we reject H naught and conclude that the average breaking strength is not 0. I mean, not 8 kilograms. All right. So this is my conclusion. This is how we do testing for a single mean. Let me do another problem. Okay, no problem over here. So Jeffrey, as an 8-year-old, established an average time of 16.3 seconds for swimming. So swimming the 15-yard, 25-yard freestyle with an SD of zero point 0.8 seconds. Is that Frank taught Jeffrey could swim 25-yard style hairstyle by using faster by using goggles. So Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 15 to 20 for 15 25-yard freestyle swims. For the 15 swims, Jeffrey's average time was 16 seconds. Frank thought the goggles helped Jeffrey to swim faster than the 16.40 seconds. So conduct a hypothesis using a alpha 0.05. Okay. So they what? You want to check whether the goggles work or not, right? First of all, set a hypothesis. H naught mu is equal to 16.43. And I want what to be true? I want this one, h1 mu less than 16.43. All right, got it. Now, my alpha is what? My alpha is given as alpha is equal to 0.05. Okay, over here, hence my z alpha is equal to what? Z alpha is equal to 1.645, right? As you can see over, this is a left tail test. This is a left tail test. Okay, for that I'll come later. That means what? I'll draw a graph over here. Okay, so it means what will be this region. Okay, so this alpha is going to be what? Minus 1.645. Okay, got it. This is a left tail test. So minus 1.645. So whatever is, OVR means, suppose you get test statistics OVR, you reject H naught. Got it? So now my Z equal to X bar minus mu by sigma by root n, which is equal to 16 minus 16.43 by sigma. Sigma is given us 0.8, 0.8 by root of 15. Okay, let me calculate it. 16 16 minus 16.43 equal to, it's going to be what? This will be 0.43 by zero point 0.8 by root 15. 0.8 by root 15. 0.8 by root 15. Root, just a second. 0.20 is going to be 0 point minus, right, 0.20. Okay, so hence we get 0.43 divided by 0.20 is going to be minus 2.15. Going to be what? Going to be minus 2.15. Okay, and because this lies over here beyond, since minus 2.15 was less than minus 1.645, hence I reject H naught and accept H1 and conclude that, and conclude that the average is less than 16.43 seconds. So what? Hence the goggles have helped. All right. So in exam, this will be given to you. Okay, this will be given to you. Don't need to worry about it. All right. You just need to know how to interpret the same. All right. So thank you and see you next video.